In this video, we're going to talk about mathematical operations. So to begin with, we can use two sliders. Let's use 9 and 2 as the example. We can do simple addition. So as you can expect, when you add 2 and 9, the result is 11, which is very simple. You can also do subtraction. 9 minus 2 equal to 7. You can also do multiplication, division, all other mathematical operations, but each time you don't have to search the full name. Instead, you can search the mathematical symbols. So by just inputting a star, this gives you a multiplication component. So if we multiply 9 by 2, this would give you 18. You can also do division. 9 divided by 2 would give us 4.5. To remove the clutter, I'm going to delete all these batteries and start with other mathematical operations, such as modulus. You can search modulus or just type percent sign. If you perform a modulus between 9 and 2, this will give you the remainder of the division. So in this case, it's going to be 1. If I have a 9 modulus 3, that's going to be 0. 4, that's going to be 1. If I do 5, that's going to be 4, because when you divide 9 by 5, the remainder is 4. That's what modulus is. It is very useful in many cases. For many batteries that perform mathematical functions, there's a zoomable battery. So let's use the addition and multiplication as an example. So when you add 9 and 5, it's going to give you 14. You can add more than two numbers. When you zoom in to the battery, you'll see this plus and minus sign. And when you click on the plus sign, the battery will add one more input, which is C. So I can use another slider, let's say 3. If I plug that into C, the battery performs an addition across all input variables, which is 17. And it applies to many others. So I can use plus icon to add a variable, or I can use minus icon to delete one. You can also calculate the negative value of any number by using negative component. So if the sum is 14, you can use the negative component to turn that into negative 14. Now let's quickly run through other common mathematical components, such as power, absolute, or square root. So power is when you raise a number by certain exponent. So in this case, let's use 5 and 2. So 5 squared equal to 25. And 5 cubed equal to 125. 5 to the fourth is 625. Absolute value is calculating the absolute of any value. If it's negative, that will be a positive. If it's positive, that will still be positive. Square root is calculating the square root of any number. So square root of 9 is a 3. Square root of 4 is 2. Square root of 5 is 2.2. Sometimes it is necessary to perform mathematical operations on a list of numbers. So to do this, I'm going to erase all of this and create a series of numbers. We know that the series of numbers by default gives us 0 to 9. And we can perform a mass addition, which adds all the numbers inside the list. To do that, we can use mass addition battery. When you add from 0 to 9, that gives you 45, like that. You can also calculate the average of a list of numbers by using average battery. So that would give you 4.5. You can also compare two numbers. To do so, Let's bring out two sliders and we can compare which one's bigger. So we can do greater than or larger than. You plug in two numbers and this would give you a true false value. So it's A greater than B. So we know it's a false because 5 is less than 8. When we slide the value on the first slider, at some point it's going to turn to true when the value of the first slider is greater than the second one. With the same logic, you can also do less than or smaller than. So compare two numbers. Is 10 less than 8? That's false. Is 5 less than 8? That's true. You can also check the equality using the equal component. Just search the equal sign. This is going to give you the equality comparison of the two batteries. So 5 and 8, they are not equal, so it's going to be false. On the other hand, there's another output that is inequality. That will be true. So if I change the second slider to 5, you'll see that the first output will turn into true. The second output will turn into false. Sometimes there's a need to convert floating point number into an integer without any decimal point. For example, if I try to divide a by 3, then this division will give me a floating point number, 2.66. I want to turn this an integer. You can give a rule whether you want to round the number or floor the number or ceiling the number. So to do that, we can use round component. This has three outputs. The first one would be a round, and since 2.66 is greater than 2.5, so the battery rounds up to 3. And the second output is floor. So this output would turn the floating value into an integer by removing all of the values below the decimal point. So in this case, although it's 2.6, which is greater than 2.5, it will just remove all the decimal points. So that's 2. On the other hand, ceiling will do the opposite. It's going to give you the smallest integer that's larger than the actual value. So in this case, 3 is the smallest integer. So if I change this to 10, then have a 3.3, ceiling would be 4, floor would be 3, and the round would be 3 too.